This is our second meetup, and we are focusing on machine learning in this one. So we will not go deeper in the, there is some echo, no? It's okay? It's strange. We'll focus on the machine learning today. We'll go through a first presentation on DCOS and how you can use it for that purpose. And then you'll see another presentation done by the Strat.io guys. We'll have some questions you can ask at the end of each presentation. We have a nice microphone. That's the first time I see that. They told me that I can just throw that on you. So it's not me who had the idea, okay? So don't blame me if you are injured. Normally it doesn't happen. But we'll have some round of questions. We have some USB keys to reward people. And we have like also a pass for the Big Data Conference, but they'll speak about that later. So let's get starting. On my side, I'll go through how you can use DCOS for creating a secure machine learning pipeline. And I will go through some slides at the beginning, and after that I'll go through several demos, so that it's a little bit more funny than just looking at slides. So hopefully everything will be working well. I don't have a lot of time, so I've prepared some of the demos. You'll see I'll explain that. So why machine learning matters? As you know, there are many, many different examples in a lot of different verticals. It can be in healthcare, it can be in industry, you can have predictive maintenance, you can have like many different usage. And what we see is that while people normally should focus on creating models and applying these models, at the end, it's not really what happens, and a lot of people need to spend time to deploy all the different pieces of infrastructure they need, things like Kafka, Spark, Hadoop, and other pieces. Then they need to work on the data, do some transformation, and then they need to build an infrastructure to serve the model in production and so on. So at the end, the time people spend in building their model is quite small. And the idea is how we can simplify the things around it so that people spend more time on building their model instead of spending time on managing infrastructure and things like that. So what we see when we discuss with customers about what they need when it comes to machine learning, obviously they need to, because we gather a lot of data, you need to store this data, you need to store that in a scalable platform, you need this platform to be secure. Then you are writing your code, and you want to be able to version your code, you want to be able to share your code with other people. Then you decide which framework you want to use to build your model, and you have tons of different options, and you always want to try new frameworks, so people would use like Spark or TensorFlow, and then they decide what they want to use, they build their code, and they want to create their model as fast as possible. That means that they want to have access to a lot of compute, they want to be able to use GPU to accelerate the work, and finally, when the model is ready, they want to be able to use it in production, to serve this model. And generally, you build a container with your model inside it, and you just like deploy this container on a Kubernetes cluster or something like that. So there are many, many different pieces that are involved. And obviously, one way could be to just use the public cloud. You just say, I need to have all these different pieces, and all these different services exist in the public cloud. But the first challenge is that all these services are proprietary. So if I start to use all the different services available in AWS, then if I get a better price from Microsoft Azure, I cannot do that. I cannot move there. Or if I want to go on-premise because there are some regulation, like RGPD or other, same thing, I cannot do that. And also, the way the billing works on these different services is not very easy to understand. So you will use things like Kinesis, for example, for messages in AWS, it will not be easy for you to know how much you will pay at the end of the month, because it will depend on many different criteria. So the idea of Mesosphere DCOS is that it only depends on machines. And when we say machine, it can be a physical machine or a virtual machine. So if you deploy it in your data center, you can deploy it bare metal. You can deploy it in a VM provided by OpenStack, a VM provided by like a VMware environment. But if it's in the cloud, you just need to use a VM like EC2 on AWS. And because we only depend on machines, then there is no lock-in. So you can get exactly the same experience anywhere. You can have the same experience in the cloud. You can start in one cloud, go to another cloud, start in a cloud, go on-premise, and so on. And then we have this Apache Mesos software that is really the foundation of DCOS, that aggregates all the resources that you have on all these different machines and allows you to consume these resources that can be RAM, CPU, GPU for different workloads. So instead of having some VMs that would be, or some physical server that would be dedicated to Kubernetes, some other would be dedicated for Spark, some other for HDFS and so on, and you get a low utilization of your hardware, you can deploy everything on the same machines. So at the end, you need less machines to run all your workloads, and you just reduce the cost of your infrastructure. And finally, DCOS is providing you with this catalog of services. So in one click, you can very easily deploy all these different components. I gave some example before, but there are many more. I'll go through that very quickly. But the main idea is that we automate the life cycle of these different services. So that means that you decide you want to deploy Kafka, for example. It will automate the deployment of Kafka. It will give you a different set of options, like do I want to have Kerberos, do I want to have TLS security, things like that. And later on, you can say, I want to have more brokers. You just change the number of brokers and click on Run. Later on, you decide you want to go to a newer version, then you can just do a rolling upgrade that is automated, and so on. So it's really a full automation of the life cycle of these different services. And obviously, that means that you have a very simple way to reduce your operational costs. And at the same time, you can focus on your application or on building your model, so you have a better time to market. So here you see the current supported services and the ones that are being added before the end of the year are in blur. So you get, like, if we focus more on the machine learning big data side, you have things like HDFS, like Spark, like TensorFlow. We have other components like NiFi, Kafka. Sometimes you have options between, like, using Kafka or Confluent platform, for example. And there are new things like Jupyter Lab that I will cover today. But obviously, in this kind of project, you also have some need for relational databases or some need for NoSQL databases and so on. So you can really have all these different components on the same platform. And as soon as you have built your model, you want to deploy that model in production. As I said, it's quite often people will just create containers and run that on Kubernetes. And that's something you can do very easily on DCOS. And we have just announced, I don't know if you've seen that, the 1.12 version, where we have a unique capability which allows you to deploy as many Kubernetes clusters as you want in the same machines. So that's really something unique in the market. You can deploy DCOS in 10 machines, for example. And on top of these 10 machines, you can decide that you will deploy, I don't know, 5 different Kubernetes clusters with different versions, one for dev, one for prod, and so on, and automate the life cycle of these different Kubernetes clusters. So as I said, one of the services we have just launched in beta currently is this Jupyter Notebook. And we'll go through that in the demo. But the main idea is that instead of having people who would build their model directly in their laptop or in their desktop, in general, big desktop with some GPU and so on, where they would have to deploy all the different dependencies they have, and then they need to write their code, they need to compile their codes, and they need to build their model and have only access to a very small amount of resources. Now they can just go and have their dedicated Jupyter Notebook environment, and you can define how much resources they are allowed to use in the overall DCOS cluster. So they can now use like a lot of GPU, a lot of CPU, and also get all the benefits of Jupyter. Who is aware of what Jupyter is, by the way? Okay, so I would say half of the people. So yeah, the main idea of Jupyter Notebook, you'll see that in the demo, is really to be able to access a web UI and to write your code, and then to just click on the play button, and basically it will compile your code and execute it. And in the way we have built this Jupyter Notebook service in DCOS, you get all the dependencies included in the notebook. So you get like the Spark dependencies, the TensorFlow dependencies, you get all the Kerberos integration done behind the scene and so on, so that you can really just focus on writing your code and accessing your data with all the security behind it. And finally, we also have this hybrid cloud capability that we have added in the previous version in 1.11, which allows you to do two things. First thing is to work with different zones, and the second thing is to work with different regions. So when we look at the zone capability, just think about it like availability zone in the public cloud. So if I deploy DCOS in AWS in Ireland, you have 3 different availability zones, and we will detect automatically these zones when you deploy DCOS. And then when you will deploy things like HDFS or Kafka or other frameworks, you can say that you want to have the different components spread across the different zones, so that if there is a zone failure, you are not impacted. And what's very popular for people who deploy DCOS on-premise is that they define generally that a zone equal a rack, so that you get some rack awareness, and I can just like tolerate a rack failure and still have like my services running. So that's for the zone concept. For the region, what we do is that you deploy DCOS normally, and DCOS is composed of masters and agents. So the masters are like where you have all the intelligence, and the agents, it's the place where we will deploy the different services. So when you deploy your first cluster, you have these masters and agents, and then you can deploy additional agents in another region. So you can say, I deploy DCOS in my data center, I have masters and agents, and then I deploy some agents in AWS, and it's another region that I can call AWS, for example, and then there is another need, and I want to use Azure. I deploy some agents in Azure, and I call this region Azure, and then after that, I can decide where I want to run my different workloads. So you can run a workload in AWS, and then you can change the rules in Marathon, and then move the workload to Azure, for example. But one thing that is quite popular is to use it for bursting. So in that case, let's say you want to have GPU to build your model, but you don't have a lot of GPU on-premise, and you don't want to invest in this GPU because you don't always use it. Then you can say, I will deploy 10 additional VMs in AWS with GPU, and I will deploy my Jupyter Notebook there, and I'll be able to start using this GPU, build my model, and just like kill everything. So that's quite popular as well. So as I said, I didn't want to go with too many slides, but if you have questions, we'll have some time at the end of my presentation, but also after that, we'll have some time when we will have some food and drinks. So on the demo side, I'll have 3 different demos. And what I've tried to do, because I don't have a lot of time in this session, I've tried to start these demos and keep the end not done, so that you can see it without having to wait a long time, because sometimes we have to download some pictures like you will see and stuff like that, and it takes some time, so just try to make it shorter. So the first demo will be about classification and spam and ham. So what we call ham, I didn't know before, is like any mail that is not a spam. And what we do here is that we have a text file where we have example of spams and hams, and we launch a Spark job that will create a model based on these different spams and hams. So this is like something I will show you here that I have already launched to get some time. So let me just try. It just takes time to go from one screen to another. So here you see I have a Spark service that has been deployed on DCOS, and this is part of the services that you have in the catalog. And this service has been deployed, and then I can access the Spark UI here. And as you can see, I have launched 2 jobs already, one that has finished by itself and one that I killed. So the first one is called Spam Ham Model Factory. And this is the one that has been used to build this model based on this text file. And basically, this is something like that. So if I just do like find here. So you run like a DCOS Spark run command, which is kind of the equivalent of a Spark submit command if you want. And you just indicate some information here because I use TLS and Kerberos, I just give some information about that. And then I just say that my text file is there, and my binary that I use to create my model is there. I submit the job, and that gets executed, and that model is then stored in HDFS. And if you look at HDFS Air, you can see that the service is also running on DCOS, that it has been deployed with high availability, so you have different name nodes, 2 name nodes, sorry. You have like different data nodes, and we have set it up with all the security, so Kerberos is enabled, and transport encryption is enabled as well, and we don't even allow unsecure communication with HDFS. So as soon as we have executed this job, what happens is that we have a model that is stored in HDFS, and the second step is just to use that text file to create and generate new messages in Kafka. So we just take some words from the spam, and we generate new kind of spam, and we take some words from the ham, and we kind of generate ham as well. And everything is stored in Kafka. But because I don't have a lot of space in this environment, I launched it the same way with the DCOS Spark run command, but I killed it. That's why you see that there is one that is killed, because I didn't want to be out of space on my Kafka environment. So obviously, now if I want to classify messages, so that's the third step, I have some messages in Kafka, and I want to consume Kafka messages and classify them using my model. I could have just done another DCOS Spark run command, but I wanted to show you a different way of doing that by using a Jupyter notebook, because that's more convenient in general when you want to write your code. So here I have a Jupyter notebook, and what you can see is that there are many different kernels available, so what we call kernel. So the thing with Jupyter is that it's very popular, but for a long time the main issue was that it was only for Python. So if you would like Python, you would use Jupyter, and you would be very happy. And if you would like to use Scala, then you would use Zeppelin, and you would be very unhappy because it was very limited compared to Jupyter. But we have one of our customers, 2 Sigma, that built a collection of kernels to allow people to use kind of any language on Jupyter notebook. And this is what we have integrated here. So you can see that we have many different languages available. And the demo here, we will use that one that is in Scala. And like you see, just a notebook, you write your code, you click on play, and basically it will execute all these different paragraphs one by one. I'll not go through the code in details, but basically I import some libraries, I create some functions, and then I execute here a Spark streaming job that is using my model and will try to classify these spams and ham, and then tell me the accuracy of this classification. Okay. So if I go in the Mesos side, I can see here that I have now 5 executors that are running to be able to classify these different messages. And what you have to note is that in a traditional Spark job, like I ran before, I have a Spark driver that is running here under the service Spark. And this Spark driver is then launching executors. But when I do the same with the Jupyter Notebook, in fact, the Jupyter Notebook itself is the driver, and is then launching directly Spark executors on Mesos, like you see here. So if I go back on my Jupyter Notebook here, I'll probably have to wait a little bit for having all these things running, and I'll see the result here. So what you can see is that we have used so far Spark, we have used Kafka, where we have stored the messages and consumed messages. The way we have deployed Kafka is that we deployed it with high availability with 3 workers, and we have also deployed it with, as I said before, Kerberos enabled and all the TLS security so that everything is encrypted. And we have also dedicated a Zookeeper instance for that Kafka service. You can also use the default Zookeeper that is running on DCOS, but that's not the best practice because it could impact the performance of DCOS. So you can deploy just like a dedicated Zookeeper for the Kafka. You can use one Zookeeper for several Kafka. You have a lot of flexibility. So like you see here, I get some results on the accuracy of my classification. I click on stop now. So this job is stopped. But on the Mesos side, I still have my executors running. The reason is that when I develop my code and I build my model, I want to be able to modify it very quickly and without having to wait for new executors to be launched and so on. So that's really convenient as a data scientist, as a developer. You can really interact very quickly with the system. But obviously, that means that if I need to do something else now, I want to get my resources back. And if I don't configure anything on top of what I've configured so far, that means that one data scientist can be kind of crazy and like run a lot of jobs and take all the resources of the cluster, and then the other data scientists will have to wait, which is something you want to avoid. And for that reason, what we've done here is that we created a quota, like you see here on the Jupyter, on this whole dev Jupyter lab, where we say that this guy cannot use more than 7 CPU and 48 GB of RAM. And currently, I'm using 5 CPU and 33 GB of RAM. So if now I want to do something else, I have to be a nice guy and to free my resources. And the way you do that is in Jupyter Lab, you just have to shut down the kernel. So as soon as I shut down the kernel here, then that means that my executors are stopped. And here, my resources will be free. And now I still have some resources available, and I can spin up another job or something like that. So that's the first demo. The second demo, if I go back to the slides here, is slightly different. So what I do here is that I try to demonstrate how people tend now to take the DevOps principle into machine learning. So we see this emergence of data ops and a lot of people taking all the best practices from this world. And here what we do is that in this demo we use NiFi to get some pictures from the Flickr API. So we get some pictures of cats and pictures of dogs to make it a little bit funny. and we store these pictures in HDFS. And as soon as we have these pictures in HDFS, we use TensorFlow to retrain a model. So that's something that is really nice and powerful, is that instead of having to learn about image classification from the beginning, from zero, with TensorFlow you can retrain an existing model, and with only like 1,000 pictures, your model can be quite efficient. So you will retrain that model to be able to now classify cats and dogs. Okay, so we run that TensorFlow job, we get that new model, and we want to apply these DevOps principles. So what we'll do is that we will push this model in a Git repository, and automatically that will trigger Jenkins pipeline that will build a Docker container. And if everything works well, then we'll launch that container in Kubernetes. Hopefully everything will be doing well, but there are a lot of components involved, so sometime it can break, but I'm sure it will not. So again, I wanted to not be too slow because just downloading these pictures on NiFi takes some time. So what I did is that I already launched the job. I will just explain what I did. So there is one job for the cats and one job for the dogs. And if I go and zoom a little bit in what they do, I have that part of the job that is getting pictures from the Flickr API. Okay, it's just based on the keywords. And then I have a loop here. So I get, every time I want to get some pictures from the Flickr API, I get a list of pictures. And then I want to have the second page and the third page and the fourth page and so on, up to the number of pages that I want to download. And then from that point, I will go here and download all the pictures. Okay? So I download all these pictures that I get from the API. And finally, now that I have downloaded these pictures, I just store them in HDFS. Okay? So I end up with, here, I will show you in HDFS. And that's another good thing that you get with the Jupyter Lab Notebook is that you have this shell access. So this is your container, basically. And you can do everything you want in this container. And here we have also Kerberos enabled. So I can see that I've already logged in with my Kerberos principal. And if I do HDFS-DFS, DFS. I'm sorry, I know that you probably want me to zoom, but I cannot. Not that I don't want, but it's just that this is not something easy to do in this notebook. So you see here I have directory cat and directory dog, and if I list there here, I will see that I have many pictures there, and can even check the number, something like 2,000 or around it. Yeah, I have 2,000 pictures, so 1,000 of cats, 1,000 of dogs. And retraining this model can take 10 minutes. That's why I just launched it here. And basically, I just run that command, python retrain.py, and I just give the HDFS directories to tell where my pictures are. And this TensorFlow job expects the directory to be the name of the different category you want to use after that. And when the job is finished, you can see that everything is stored in /tmp. So if I go to /tmp here, you see I have 2 output files. So these are my model and the description of my model. So now that I get these things, I want to go to my directory where I have my Git repository. And I can show you here that I have already pushed one time my code for my web application that I will deploy later on Kubernetes. But the only thing that is missing is the model. Okay, so there is no output something here. So I'll just go and add this model in my repository. So I just do a /tmp output star here and do a commit. add. That will be better. Okay, so now what it happens is that I push my model to my Git repository. And here, if I refresh the page, I can see that I now have my output that should be there in a minute. Or not. Perhaps it's there, I don't remember. Yeah, it should be there anyway. So what happened is that I have then configured Jenkins. Again, all these things are running on DCOS. So I have GitLab running on DCOS. I have Jenkins running on DCOS as well. And I have just configured Jenkins so that I have a pipeline here. And this pipeline basically automatically look at this repository every minute and see if there is a new commit. And you can see here, this is my, my repository and the credential I want to use to connect there. And then it looks at a file called Jenkins file. And this file is telling Jenkins what to do. So I have that here. If I go to Jenkins file, I even have open here. So what this file is doing is that it gets the code from the Git repository, and it builds an image, a Docker image, based on that. Okay. So I will build my Docker image. I will push that image to GitHub, to Docker Hub, sorry. And finally, I have just some commands at the end that will run that container in the Kubernetes cluster that I have just deployed as well. So let me just check here if everything is working or not. It is progressing, which is good. What you can see as well is that the Jenkins executor is created on demand on Mesos. So when you need to run pipelines, an executor is created, it builds everything, and then after some time just is deleted, so you don't even use resources on your cluster when you don't build anything. And if I go there, I can even look at the output and see how it progresses. Like you see here, it's getting the base image, and then it will build everything with it. And that gives me some time to just show you that here, I have deployed one Kubernetes cluster here, and this is a Kubernetes cluster with 3 private nodes and 1 public node. Like I said before, you can deploy as many Kubernetes clusters as you want. Every time we deploy a Kubernetes cluster, you decide how many public and private nodes you want to deploy, and you can also define where you want to run them. If you really want to have them on dedicated hardware, you can. But the big value of DCOS is that you can run all of them on the same machines. And we always as well deploy a Calico cluster. That means that you have like your software-defined networking that is available natively in your Kubernetes cluster. And what it means for you at the end is that you can create network policies. So you can say this pod can discuss with this other pod, or this pod can access internet, or things like that. So if I go back, I think that should be done. That is, yeah, that's still building the container. And what I will do, I will just to make sure I'm not becoming late, I'll just go through the last demo and then we'll go back again. So the last demo is just, what I did here, I just retrained a model using a TensorFlow job, but it was like it was not a distributed TensorFlow. And the problem with TensorFlow is that when you want to distribute TensorFlow, it's kind of, if you have to create a new TensorFlow cluster, let's say, for each job you want to submit. That's kind of the way it has been architected. And that's really painful. You lose a lot of time doing that. And the way we think is really easier to do it is to use a project that has been open sourced by Yahoo that's called TensorFlow on Spark. And basically, you slightly modify your TensorFlow job, and then you can submit it, and basically, you use Spark as a cluster environment to run your TensorFlow job. And the idea of this demo is to show that in action with the MNIST dataset, which is like a dataset of pictures of numbers, and that is used in general to compare the efficiency of your models and things like that. So what I did is that I just downloaded this dataset, and I stored that on HDFS, and I can launch a Spark job. Obviously, I could have used a notebook approach and define all my code that way, but that would not be very easy with a distributed job like that. And the way we will do it, it's another way again, which basically involves a Spark submit directly in your Jupyter Lab environment. And the beauty is that we have this Spark opt here option that is already populated for you when you deploy the Jupyter Lab notebook. So it includes everything that needs to be used for Kerberos, for TLS, and so on. Normally, you would have to submit a very complex job, like with probably 30 lines or whatever. But because we have embedded everything in this environment variable, you don't have to worry about it, and you can just focus on the different options you want to use for your job. So if I go in the Jupyter Lab notebook here, and I am at the root level, I have already downloaded the TensorFlow on Spark code, like you can see here, and I can just execute this job. And what will happen is that, a little bit like I did before, we will see the executors here coming. That will be a Spark executor that will run my TensorFlow job. But here, what I'm doing, which is different than what I did before, is that I'm using GPU to run that job. Okay, so that also shows the benefits of being able to leverage GPU when you build your model. So if I just go on the roles here, I see that I have some GPU consumed here. Okay, so my two executors are using GPUs. So now, let me just go back to the demo that seems to be okay. I've seen a success quickly, which is quite good. I have exposed automatically my web application using Traffic, and I should be able to access it if I remember the port, which is not something I'm sure I remember. That was that one. No. Yes. So the idea is that now I have a model that knows how to recognize cats and dogs. So I can go there, select a cat, do uploads, and then see if it recognizes that it's a cat. It can. It should show me the picture here, but there is some caching. Yeah, so it's better. So I can do the same with the dog. And in general, it works better with cats. Don't ask me why. But still, it's not bad. And to finish with something a little bit funny, we'll try to make it a little bit crazy. And to confuse it. And then it really depends on the images we have downloaded on Flickr. The result is always a little bit different, but we just try to classify something that is kind of a cat and a dog. And then you have more dogs this time. It really depends. So that's kind of it. Just can check here. I will not wait for it to finish, but you see it was just like the TensorFlow and Spark job that is still running there. So let's see if you have a few questions before I let the other presenter doing his part. Any question? You have. Oh, you really want me to try that stuff, right? So let me check if I understood everything. I have to make it. All at the end? Okay, no problem. So just keep your questions, remember it, and we'll go through that at the end. Good. Thank you.
Um, Today I'll talk a little bit about how we can actually put in production things like Denis mentioned. So sorry to say, we have tools to develop our model. We have different options, right? We can run a Spark. But I'm actually trying to focus a little bit, the first part, on understanding what's the focus of Stratio, which we call it data-centric. Let's see if I can give you a little overview of it. Then I'll show you basically when we show these kind of tools, right? The first things we get is, okay, well, how can I ensure that I can have audit? How can I ensure that I have the certain levels of security? I mean, if it's pretty typical that you go to a financial institution and then they will ask to certain security requirements. So I'll try to draw some of them today based on past experience that we have in other projects. And then I'll try to explain how we actually develop models and how we put them in production, so to say. So I'll start with this. It's a bit of a sales slide, but I'll try to explain why. The reason is that when we actually go to a company and then we start talking with them and then asking for what are your problems in general, they tend to have something like this. They have very specific software that are solving specific applications that, for example, a call center is basically doing things for the customer experience. You will have typically a mobile app system, and it's usually managed by different organizations and people. So what tends to be is basically that each one has their own data. They don't really understand and know what are on the other sides. And it's really difficult to share it and share knowledge between these organizations. So traditionally, what we have done is basically put everything into a big data lake and try to start correlating this information to see if we can actually get something out of it. But in the end, what this means is, okay, you have the traditional operational systems, but also a new system that is called your big data lake, where you actually have to maintain and do your analysis or whatever you are trying to do. So this actually puts a lot of problems. I think Denis mentioned some of them as well, where you actually have to deal a lot with infrastructure, where you actually have a very slow time to market and these kind of things that makes a company pretty slow. Basically, they don't focus on developing what they need, but they also have to deal with this type of questions. So what we're trying to do is, okay, let's put this data-centric concept, which basically means that let's try to govern and have our core will be our data. So we'll basically have applications around it, and we'll try to share this data between applications and processes. So what we are trying to do is basically, for example, if we focus on the e-commerce, we'll try to use that data as long as we have it available. So we believe that we don't want to force anyone to use a single system to store their data, because that's not really what is useful in the end, because you cannot force an application to use, okay, you'll use Postgres today, or you use MySQL today. So we have to adapt to the kind of storage or type of storage that each application has. So what we are trying to do here is basically, okay, let's govern this data, let's secure it, and then let's expose it so others can consume and trade that data as well. So the main objective here is that each of these applications can actually publish or have registered this data so others can consume and write or read into it, right? Having said that, I mean, we use, for doing that, this multi-data store and multi-processing, we use DCOS, right? So the main objective is that, okay, we can combine different workloads and we can combine different data stores, and we actually have some policies around it to control what kind of accesses, what kind of policies we imposed on these applications and data. Right? So We have developed, I'm not going to go into too much detail here, but some of these products are the ones that we are developing in Stratio to actually achieve that. So starting from the left, so we have what we call Stratio EOS, which is based on DCOS, right? Which is basically an infrastructure and platform. Cross data, Sparta Intelligence that we will see today, and then some others that we'll use to govern data, manage the secure centrally, and offer operational capabilities with the last one, with microservice framework. So what are the non-functional requirements? If we go to this picture, right, we want to govern all the data in a centralized way. We will impose some certain requirements on the system. So how we are designing or how we are developing these modules, so to say, is basically following. There might be more, but the main ones are basically 4. Right? We have some certain security levels and profiling. So the data that we put in, it's important that we are able to actually expose and control who actually can access it, right? So the very first requirement, if we want to go to a picture like that, is having kind of provided mechanisms to support encrypted communication, support authentication and authorization, and also it should be easy to manage, because if we have that kind of landscape where everyone can actually go and put data or read data there, we actually need that this security is easy to do, or easy to manage. So we will do that through a centralized component which we call GoSec. Okay? Then we have isolation of resources. Basically, this is we bring a lot of this functionality from DCOS and Calico, right? So what we are trying to do is that as we will mix processes, operational applications with big data processes, we need to guarantee that one doesn't step into other resources. So to say, if you are actually running an operational application, we cannot go and run a Spark job and then screw the performance of the first one. So we are trying to make sure that we can isolate on the network side, and we can isolate on the resources like CPU, RAM, or disk on each application. Then we have the data governance tools. This is basically, as we are going to govern on this data, we are not trying to model as we typically do in, for example, big data lakes. We will try to use another approach, which basically will be, we will auto-discover the data sources that are governed, and then we'll try to link those with the business requirements. So you'll have something like a data dictionary, which is a technical map of your data in this governed multi-data store. But also you have the capability to link that to business terms. So you actually make sense of what you are storing there. And it's one of the most important parts when you actually want to reuse those data. I'm not going today too much into this, but this is something that we could do another meetup about. And then the last one is the DevOps productionalization, which basically means that we have some tools, as Denis mentioned, in Mesosphere or in DCOS. We actually can offer like Jupyter or Spark, and it's out of the sort of say out of the box, right? The main problem that we are facing is, okay, once we develop these models and once we develop these applications, how we actually put them in production so these other applications can read and take advantage of the results, for example, of a logistic regression, right? So this will be one of the main part of the demo today. So we're starting with the security, right, just to talk a little bit about it. We will have like 3 main things that a microservice or a Docker container will need to do. So in the first place, any applications that will run on our system, we usually try to secure it at a user level. So what we'll try to do is, okay, we will put that microservice or application an SSO, a single sign-on layer. So basically, each time you will go to a Jupyter notebook, for example, you have to authenticate to to see who you are, right? Because that will mean that each time you will run or you will do something, or to read or to write or to treat any kind of data or application, you'll be identified inside the platform. The second one is the policies. The policies, we use them especially for centralizing this management of security. So we will define, once we know who each user is, we can apply them different policy security. So we could say, for example, that user A can only read from HDFS and not read from process, for example. So it's pretty easy to profile each user that is logged inside the platform. And then the last one is the audit. If you, I don't know if any of you come from a financial institution or a bank, but this is one of the most important headaches that some people have there, because regulators, in general, the law enforces them to have very strict requirements on how they actually access and treat data. So it's pretty interesting for them to have a real map on how, for example, an scoring on a client actually is reaching that score, right? So a typical question of a regulator would be, okay, can you explain me what's the cycle to know if this client is good for a scoring or a bad score? So that's what you use when we audit. So each of these microservices need to be able to have the tools to be audited at any time. And then the last one, it's maybe a little bit cumbersome as well, that we have everyone logged in, right? But we need to ensure as well that not anyone can sniff on our communication. So basically, each microservice need to enforce encryption between them. It doesn't matter if we are Spark and reading from HDFS or reading from Kafka, or we are an operational microservice that wants to contact another one. We have some secret manager, so to say, is based on Vault, which basically manages all the secrets and passwords applications that all the applications inside this platform are running. So any of those microservices in this case could take their valid certificate and then start communicating with the others in a controlled way with certified certificates. The second one is probably the most related with DCOS. As I said, the platform is based in DCOS and Calico. So what we are doing basically is, if we have in a single machine a microservice and a big data process, we ensure that basically none of these components can overstep on others' resources. So we will do that using DCOS mechanisms, basically. Then the data governance tools, I'll go a little bit faster. I don't get too much. The data governance tools is basically answering some questions regarding the governance of the data. So we have a big data tool that we want to analyze. And typical questions will be like, on the data security side, okay, who are you? You are an authorized user. If you are, then you will perform actions or not. And then the more related data processes development will answer questions typically like, okay, if I read from this table, let's say, is it a personal data? So I need to follow some regulation or not? Who has created this? Can I delete this record? These kind of questions will be helped or eased using kind of these three components. The data dictionary basically will give us a map of information of what we have registered in the platform. The business glossary will try to correlate this data dictionary with business terms. So, for example, if it's confidential data, you can mark those tables or those fields that they are confidential data, and the platform will treat them as confidential data in the processes later. And then the last one is what we call lineage. Lineage is a bit related with audit, but it's on the kind of the schema level. So each time a process is run on top of a table, it will be something like a record is left on the lineage, so to say, system. Right? So you could see like a table is run by some process and where and so on. And the last one is the DevOps productionalization mechanism. So basically, when we deploy, we need to manage the whole cycle, or we need to monitor, we need to evaluate in the case of an application or a machine learning model. And then we need to manage and have the history and versioning of those that we have developed. So today I'll speak a bit more in the functional case now, having this in mind. I'll go to the demo, basically. The demo is taken from a financial institution, so it's kind of a real case. And the main problem that these people had is that, okay, we have valid models developed by us. This is written in Python, right? So let's say it's a logistic regression, right? So their main problem was that, okay, how we actually put this in production? That was the main question. I have a logistic regression model that is just one of my inputs for the real scoring decision. So my scoring is basically done in the first two steps. We need to calculate the model, which is based on machine learning. And then we need to apply some extra rules that will follow some checks. I mean, it's policy records. I don't know if someone understands that the hint list, if it's the CRIF, some sort of financial terms, right? That you will give them a clue if these people is actually they actually didn't pay anything. Let's say they are default, or they have police records, or they not. So they will put, depending on those things, they will put a score on green, yellow, or red, right? And then the last one is basically they want to use that, for example, in the CRM system. They want to use that in the machine that actually calculates how much money this bank can loan these people. So based on this scoring, they will actually push that into the operational side, so they can actually take that into account when they are actually giving a loan to a certain person. Right, so basically the demo, I will not go too much into detail on the Jupyter lab, but I want you to understand what are the different parts to actually develop this kind of a scenario. So the first one was basically a data exploration, where also a Jupyter lab, where we actually are exploring what is our data set, what kind of fields we have from our clients, what can we use, or is interesting to use to do this model. Then I'll go through data preparation. What you are seeing here is basically a flow. It's based on one of the tools that also it's called Sparta, which basically is preparing the data to input the logistic regression model. Then we'll have some data validations to actually check that this model is valid. And then we will productionize this workflow based on versioning and actually reading that version from the model, loading them, and then applying these extra rules that we talk about. And then the last part is basically the evaluation. So we have another flow, which is basically trying to understand if we give Go a score. We actually try to detect if that client went to default, which basically means that he didn't pay, or he actually was a correct decision and the loan that we gave was good, basically. Okay. So I'll go to the demo. Okay, so this is how basically Sparta looks like. Also, you maybe first the DCOS side. So this is a service running on top of DCOS. You see that we have already a deployed microservice with the model. We have our analytic environment, which basically is one container for each user that is logged. We also have the service that I'm showing you, and then this is a little bit the same as Denis showed already. So basically, this is just showing all the processes that are currently in this environment. I'm using now Stratio SaaS, which is a shared environment between different clients, our POCs. So our demo is just one tenant on top of it. So to start, I'll just let me see if okay. So I have these three models, right? Also, I will start with the explore part. So you see that a notebook, right? We are actually loading now our data. We are looking for different, looking for some statistics, what are interesting features to use in our model. And then we will try to train that model. So in our case, as we were not sure which kind of model was interesting for us, we will try to compare. You see here logistic regression, K-neighbor, some random forest classifiers. So we'll take the best out of it, having the best accuracy, and then we will try to publish that so these flows can use it afterwards. How we actually doing that is basically in Jupyter we have integrated what we call magic commands. So these magic commands, what they do is basically you can publish this model in two ways. You have one way that is the batch way, which basically will store this model in HDFS, and then we can use another flow to load it and apply it on the model. Or we'll try to use the microservice way, which basically will create a microservice automatically with this model inside. So it can be exploited by a REST interface. So in this case, I'll use the batch one, right? I'll show you a little bit more how we're actually developing the one flow. So in this scenario, or this tool is actually running a Spark underneath. So what we are doing here is giving an editor, so a user can basically define a flow and then translate it automatically into Spark processes. So we feed some helper tools like this debug. I want to show you this one only, and then I'll continue. This will basically try to check that I'm reading certain information from our client historic data, and then try to basically remove some fields that are not useful. And basically, I can show you the whole flow. Sorry, because I don't see it very well from here. The good part of this is that each time you develop any new transformation, or you are actually following this flow, you actually have some help, because you can see here the schema, right? It's listed here, but also some sample data. So you can try to deploy and actually develop your flow using the logic with a few records that actually help you to see if the logic is good or not. So each of these tasks basically are doing simple things like remove columns or rename some column or apply some quality rules in this case. So I'll show you the interesting one maybe, which is the calculation of the score. This one. Okay, so a little bit long, but what we are doing here is basically we are reading our client's information. I'll show you the debug. So we load 10 records out of all of them, and then we will execute this model. The model we are executing in this case, it's called risk scoring. Right. We can see here that we have a few of them. I'm jumping a bit, but yeah, we have a more deep session if you want. But we have these models that I'm showing you before from Jupyter, and we're actually deploying them on a repository model. So basically, we have, as you can see, different versions of our risk scoring model. And in this one, we'll try just to point to the version 2. So in this flow, if we actually execute it, what we will do is, using this entry, we'll try to predict or to apply the prediction of each of these records. So in this case, what you are seeing is, okay, I have this client with age 67 years, this credit amount, some other features that we are using. And then we are actually calculating that the probability that this client gives default or basically doesn't pay is basically none. So this is a good client for our bank, right? We will find some others that have one when it's actually not a good like this one. Right? This is actually not a good client. Basically, we will score it as a red. So once we have that, and you are seeing that now I'm basically executing a model, and with the capability that I can apply more rules based on the output that this model is giving me. So what we are doing later on is basically mixing it with the hint list and applying all those rules that I was explaining before. So if I go here a little bit more. So you see that I'm loading another list, which is the hint list, which basically has, if it's this client has police records or it's actually the default in another financial institution or anything like that. And then apply all these checks on top of it to set if this client has a red decision, which in my test data set is actually 8, right? Or it's yellow or green. Right. You can see that it's pretty easy to develop. I mean, we actually did this example with a business guy. So he actually were saying us in real time what kind of rules we had to apply when developing this model. So, and the last one, I won't take it much longer, is just how we can evaluate that flow. So, using the same concept, we will use another flow where we actually So we'll see basically that with the clients that we have detected were good or bad, based on that score, we'll try to model if the good ones and the ones that we gave a loan, basically, were good or were bad. So in our case, in a test scenario, we're actually achieving 97% of success, which basically means that a few of them actually did default, which basically means that we put them in the green category, but on the end, they actually resulted to end, or they ended up not paying the loan given. So they were actually or we shouldn't have given the loan, basically. Yeah, I don't think I will use more time because it's already 2023. So Yeah, if you have any questions, maybe I can answer them, or maybe to Denis. Yeah. I think you're better at me. There you go. So, any question?
So guys, any question? Yes.
Hola. Hi. Well, my question for Denis. I saw that or most of the Spark submits that you put was on Kubernetes. I think I saw.
No, I did the DCOS Spark Summit at the beginning, which was running the job on the DCOS Spark service that is on Marathon. And then when I was doing the Jupyter Lab approach, when I was clicking on play, it was launching Spark executors on Marathon. And the same when I was doing Eval Spark Summit at the end. Because perhaps I can elaborate a little bit, but you see some trends also where people try to run all these different things on top of Kubernetes. We have things like Kubeflow or stuff like that. And obviously, you can do some stuff like that. We think it's more mature on DCOS because we are doing that since years now. And it means that we have integrated all the security, high availability. We are able to managing GPU, which is not something you can do. Normally, you can use GPU with Kubernetes, but you cannot limit its usage, which is kind of a big problem when you want to share resources. And also, even if you use Kubeflow, you still need Kafka, perhaps outside, or HDFS somewhere else. So in any case, you need other stuff. So obviously, there are a lot of things that are done on Kubernetes. We are following it. People can use Kubernetes on DCOS. Also, if they find that at some point in time it's better to use something on Kubernetes instead of using our integrated services, they can. But currently, we don't think it's really useful.
Toma ti. I think so. I'll try. This one's for you. I did the first.
Hi. You have been talking about technology like Spark and HDFS. How does DCOS work with things like data locality? I don't know if I explain myself.
Yeah, no, I think that's a good question. So I would say you cannot get real data locality like you would get when you use the traditional yarn cluster and things like that. But what we've seen so far is that data locality was very important with 1 gigabit networks, because at that point in time, the network was the bottleneck. But currently, what we see is that all our customers are using 10 gig networks. And basically, if you are using data locality, perhaps you can be a little bit faster, but it's not that common, especially because we focus on things like Spark or in-memory computation. And in my previous life, I was at Delhi MC, and I have some colleagues here, and we were doing a test with object storage, for example, which is a lot slower than just having storage outside of your at another node. And basically, with Spark, we didn't see even difference with object storage, just to give you an idea. Now, if you use things like HBase or very low latency sensitive frameworks, that can have a difference, but this is not our focus. You really focus on Spark, TensorFlow, all the new frameworks that people tend to use when they start new projects. Make sense?
Yes.
I think everyone wants to have beers, right? I don't even know if there are beers. I said that. I hope there are beers, right? Okay. Thank you, guys.
Okay, so the last part and the most funny one is that we are today making some sort of a lottery, right, to give out a ticket for the Big Data Spain, which is taking place on the 14th and 15th of November. The first one was a training, but that was canceled on the last second, so you are very welcome to come to the welcome note, which is done by our CEO, Oscar. And then we have 3 talks. One is done by Denis, I think, yeah? And the other 2 are from Stratio. I'll give you a little bit of a clue what we are working now and what will be presented in this Big Data Spain. And based on that, we'll do the lottery. So Stratio is working basically on the most maybe innovative part of the company on machine learning capabilities. So we are working hard on facial recognition, which basically means that a machine can understand the face of what someone is feeling, basically. No, not feeling, sorry, that's the second one. The first one is basically recognizing the person itself. So we want to make a system that is capable of saying, okay, you are Pepito or you are Juanito, okay? The second one is basically trying to detect if this person is happy or this mix of emotion through the face of this person. The third one is basically following the first one, is trying to classify objects or to recognize certain objects if we show them a video or an image. So it will typically say that, okay, he can detect, I don't know, a computer or typical things that we can train it to understand. Then we have the natural interaction, which is more on the way or more in the side that we want it to basically interact with the humans. So basically we are giving them the capability to talk, right? We're giving them the capability to understand the content of documents. We're giving the capability to give them some context. Let's say it's not the same if you ask a question on a certain context or another. So these machines should understand which context is it running. And then the last one is basically trying to reach conclusions based on those things and actually have certain conversation with you or with someone interacting with this machine. So I'll show you just a video, right, to make an introduction to the Big Data Spain talk this year, which basically is a person that will see this robot or this agent for the first time. So we'll try to detect if he's happy, he is not, he is angry, or he is whatever emotion. So in general, we have, based on psychology books and research, we have like 2 types of mixed emotions. So we can detect happiness or sadness, which are opposite, it's one to another one. And then we also have 2 that is kind of anger and surprise, which are also antagonists between them. So the blue line that you see on the top left is basically is detecting if the person is happy or sad. And then the red one will try to see if he is surprised or he is angry when he sees the video for the first time. So he's starting to understand that he is happy, you see? So the blue line goes really up. He is actually going out of the normal parameters because he is pretty happy to see the agent, right? And now when he actually turns back to a normal position, so this line will go down again. So now he's starting to be normal again, so the emotion goes down again. So the context or the draw that what I want you to do today is basically think of think of a use case where you would apply these capabilities. So basically, based on your experience or your industry or whatever activity you want to show. Basically, I want you to think a nice use case or something that you would like to see using this kind of capabilities on a machine. So the context, I think Sylvia has some papers there where you can actually write an idea, put your name on it and your email, and basically we'll choose the best idea that we think or the best use case to try out with these capabilities. Also with any other of analytics or big data that you can think of. So you can combine a normal or a typical use case that you would do today, but using also things like, I don't know, question answering or semantic document retrieval or anything you can think of. So you're very welcome to participate. Just put your, as I said, the idea, the name, and the email to give you the ticket, basically. So thank you, and hope you want to participate.